Hi guys, welcome back. In my previous video, I went over some of the potential problems that we could be facing with the widespread adoption of UAVs. Today I'm here to go over in detail some of the specifics of UTM, also known as UAV Air Traffic Management, and specifically within UTM, two main primary issues that need to be addressed. The first one is Automatic Issue Identification, also known as AII. And the second one is Automatic Task Distribution, also known as ATD. Ultimately, the goal here is to enable a widespread adoption of UAVs by building a powerful UTM. The reason I've been interested and focused in ATD is because really it sits right there at the heart and core of UTM. At the end of the day, it really all boils down to who needs to do what, where, when, and how. So building a powerful and solid infrastructure for ATD is really crucial to a functioning UTM. I think the simplest way to state the objective of ATD is the right resource with the right skill set is assign the right task at the right time at the lowest possible cost. The first step toward developing such a system would be to first list all the possible mission scenarios and task distributions. To name a few, these would include providing flight path changes to UAVs traveling in bad weather, or controlling movement of UAV traffic between altitude sectors. These would fall under the Automatic Issue Identification system. To improve the efficiency, the AII should integrate a push versus pull model of categorization. In other words, the AII categorizes tasks as either push tasks or pull tasks. Now, pull tasks are push tasks which require an ATA's immediate attention. These can be characterized as high priority, mission critical tasks that must be addressed immediately. Some examples of push tasks would include rescue operations or providing flight path changes to UAVs traveling in bad weather. Pull tasks, on the other hand, are those which allow the ATA some flexibility in choosing which task he or she wants to undertake. These are not mission critical tasks, and some examples would include reporting, documentation, completing daily activity reports, that kind of thing. In addition to categorization, the AII should be able to prioritize tasks. Of course, if a task is categorized as a push task, it is by default a high priority task. But you have to remember that there are going to be a lot of push tasks, so being able to prioritize among them is going to be key. Of course, the same goes for pull tasks. Now, when prioritizing tasks, a key issue to realize is that it may be relative to other tasks at that point of time. Now, what I mean by that is, say for instance, you have a mission critical task at one point of time, because relative to other missions, it has a higher priority. That same task could be deemed as not mission critical at another point of time, because relative to other tasks, it has a lower priority. Also, a low priority task that has not been performed by its due date or even a little after may become a high priority task. So as you can see, a constant monitoring process system must be in place in order to continuously categorize, prioritize, and assign tasks. Ideally, the ATD should be intelligent enough to prioritize and categorize a mission at any point of time. The next step is to list, understand, and prioritize the factors affecting task distribution. Some of these factors would include availability, experience, qualifications, skill sets, requirements, constraints, regulatory compliance, that kind of thing. It is essential to prioritize these factors because doing so and gauging a sense of what you have more and less of directly impacts task distribution. Suppose, for instance, there are 20 people who are qualified and available to perform a specific task. Now, out of those 20 people, 10 are unable to conduct the task due to contractual constraints. Out of those 10 remaining people, another 5 are unable to perform the task due to language barriers. As you can see, the original list of 20 is now dwindled to just 5. If these factors are not prioritized and taken into consideration, and the task is assigned to any of the 20 people, then there's a 75% chance that the task would be assigned to someone who's unable to perform it. As you can see, prioritizing these factors is not an easy task. There is not a specific answer as to which factor has a higher priority. One possible route, for example, could be through supply and demand. Factors that have the least scope should be given the highest priority. Ideally, the ATD should be intelligent enough to make high-level decisions. For example, suppose you have a medium-level task. Based on availability, there are 2 people, an expert and a novice. Who would you give it to? Giving it to the expert may provide a sense of confidence and assurance in terms of ensuring that the task is completed efficiently and accurately. However, at the same time, if this kind of mentality persists, then how will the novice receive the experience and exposure to graduate from a novice to an expert? As you can see, ATD may seem simple, but there are always ways to make it more complex, as you can tell by this example. Now, an optimal ATD should effectively be able to integrate a semi-automated system by blending autonomous tasks with manually operated tasks. The semi-automated system must be able to identify which tasks must be sent to the automated portion of the ATD and which tasks can be sent to the manual portion of the ATD. One option to consider is to send mission-critical push missions to the fully automated server, because push missions tend to be dealt with rapidly, but human picking and choosing may take time, while reserving lower priority pull missions to the semi-automated server. Others may argue that the other way is better. In other words, sending lower priority pull missions to the fully automated server, while reserving mission-critical push tasks to the semi-automated server. That way, a human override may ensure a level of safety for these tasks. Another area for expansion is to store all the assignment engine results in a database. That way, the ATD can do some data mining, see if there have been similar situations in the past, examine how the results turned out, and then go on from there, carry on from there in terms of assigning a task, in terms of being able to identify the factors and choosing which task should be assigned to the right resource. As you can see, the area of UTM is very vast. I've just provided some areas of interest with regards to ATD and AII. No doubt there is still way more to be explored and discovered. So I really thank you for watching, and stay tuned for more on this topic.